Welcome to episode 4. The subject is today digital twin. A digital twin is very close to a model-based systems engineering model and perhaps a little bit more connected to the real world objects using sensors, edge computing and things like that. It says that the digital twin is a digital representation of a real-world entity or system. I think it's very important that the physical asset contributes with live IoT data, sensor data, or conclusions drawn by edge computing of the physical assets. So I think this real-time operational data is very important. Of course, we have the maintenance history of the digital twin. We have the operational history of the digital twin. Predictions about failure rates and things like that from FMEA and also CAD models is of course important to visualize things, videos how to deal with things, and also finite element analysis models. But without real-time operational data, I don't think it's a twin. Then there are no connection between the physical asset and the digital twin. A digital twin is very close to what a model-based definition is. Many CAD tools, PDM tool vendors, PLM tool vendors that also have a CAD tool, PDM tool connected, they like it to be something very close to the shape. For me, behavior and the possibility to give context to all this operational data that you gather is as important as the shape. Of course, we need shape, geometry, topology, logic, constraints, how things can move, how things act, and so on. But behavior is with materials, processes, dimensions, tolerances, physics, mechanics, how things move, they are very important. And also the context. How did the product look like when we gathered this information? How was it produced? How was it used? What parts were retired, and so on. These are very important things of a digital twin. And that's when I think that what we have in PLCS that we talk a lot about is exactly that. We deal with all these things in a consolidated, integrated manner. You also see the digital thread that we talked about in the last episode. And by using the digital thread, and we can, through the life cycle of a product that has a digital twin, maintain the digital twin. And we could use the digital twin as a source of information using the digital thread and go back to feedback to earlier phases of the product life cycle. So digital twin and digital thread are very connected. A little bit simpler picture. How do we build a digital twin? Says we have project data. Yes, it could be a house or something like that. But we also have data how we build things. And then we have built it, and then we have as-built data. How the product looked like when it was instantiated in the real world with real properties and so on. And then we combine that with sensor data. Sensor data connected to the physical item. If it's a house, then they are all over the house, and then we have the digital twin of the house in the computers, and we have the possibility to measure data, get data, digital data out of the sensors representing different things in the house. And these are combined, then we connect the digital and the physical, and we have a very good representation of a digital twin to draw conclusions from. Since we are a PLCS connected company, we have looked into this. And this picture, we have our product ShareAspace there, which is based on PLCS. But if we start from the left, we have real world products. And of course, for a long time, we have been able to support that you do human readings, human observations. You see something, and the human make conclusions and make an observation, and put that in, connected to the physical item in the digital twin in the PLCS space, ShareAspace. But with machine reading, we apply something very similar. We have machine readings coming, many sensor readings a second, and then we have stream analytics looking for discrepancies, things that seems to be happening outside the normal. And when something like that happens, we create a digital created observation and connect that to the ShareAspace. In ShareAspace, we get the context. We know exactly how the product looked like, the configuration of it, how it was used at that time when this came, and so on. The rest of the stream analytics, and even what is recorded and create the observation from, we store that in a data lake. Why do we do that? Yeah, because to know what to look for, then you need to have some knowledge. It could happen that we don't have all the knowledge about this product, but we learn over time. Then it's very good to be able to go back to the raw data. We have a connection between the data lake and the ShareAspace context-given digital twin using common IDs, and then we could do analysis, applying machine learning on this, using raw data and context from the production configuration, product configuration or production configuration, and build new knowledge. We believe that this is a way for the future. We combine big data, stream analytics, machine learning, very structured data in PLCS, in ShareAspace, connected to maintenance, repair and overhaul, PLM, ERP. I hope you got an understanding of our belief of what digital twin is. It's very much connected to model-based systems engineering. It's very much connected to digital thread, and it's very much connected to product lifecycle support, which I believe is a very good enabler for this. Thank you.